Okay, guys. So, machine learning, data science, artificial intelligence, everything will come under one tree only. Data science, machine learning, deep learning. You will be listening all these tools. Uh, Artificial intelligence, uh, natural language processing, uh, computer vision. Large language models. So nowadays it's not introduced. So that's why for this batch I'm explaining this large language models also. So now here, what are the multiple types we do? So in the data science or machine learning or deep learning, artificial intelligence, whatever it is, and we have discussed and we have discussed and we have discussed what is natural language processing and what is computer vision also. So now let us see the basics of machine learning. So and what are the concepts are there behind machine learning? So the first thing is unsupervised learning. So unsupervised learning. And next thing is supervised learning. So within unsupervised learning, the simple answer you will be getting in the question. What is unsupervised learning? What is supervised learning? So definition is if there is no target data available, that will be called as unsupervised learning. This is also one of the interrogation. Some guys don't know this definition also. What is unsupervised learning? If there is no target data or target feature or target column. We have already discussed what is target and what is feature. So same scenario, if you have target feature available, that will be called as supervised learning. Simply. Just copy everything, paste it there. If there is here in the unsupervised, no will come. Here, target will come. So target data or target feature or target column will be available. That will be called as supervised learning. That's all. So next, algorithms. What are the algorithms available for this unsupervised learning? Same scenario, but the thing is in supervised learning, it is divided into two types. This supervised learning, whatever the supervised learning we take, so it's divided into two types. One is classification and another one is regression. Supervised. If you are listening the session once, there is no need to reread it again. So that's why you should remember each and every concept clearly. You should be in the situation to distinguish unsupervised learning and supervised learning, everything clearly. Supervised learning is divided into two types. So here, type 1, classification. So in the type 2 regression. Same unsupervised learning also we do have. It is also used in two different ways. First one is dimensionality reduction. Or in first one you can make it as clustering algorithms. First one is clustering algorithms. Next one is dimensionality reduction. So normally this clustering algorithms is the main thing, and this dimensionality reduction, it is also will be called as unsupervised learning only. So in the supervised, we do have classification. Here we do have regression. Here we do have clustering, and here we do have dimensionality reduction. Let us see one by one. So in the clustering algorithm, what we will be getting? What are the algorithms we are getting? So that is what let us check. So there are multiple algorithms are there, like K-means algorithm is one of the technique. So like hierarchical clustering. So like that you have 3 to 4 algorithms. At least you should need to remember 2 or 3 algorithms. That is enough. So let us go to Java T-Point and let us read it. Java T-Point is the best source where you can read multiple theory related to multiple concepts. So either you can use machine learning related thing, Java related thing, whatever it is. At the starting itself, it is mentioning multiple algorithms available here. Out of all these algorithms, K-means algorithm is an important thing. And apart from that, some other algorithms like DBScan algorithm is there. So first algorithm is K-means algorithm, and the next algorithm is agglomerative clustering. Agglomerative clustering is another technique, and we do have some other techniques also there. So in the agglomerative itself, the one time is hierarchical clustering. So if the data is clustered into multiple groups in the hierarchical level, that's why it is called as hierarchical clustering. So we will be discussing at least 3 algorithms here. So we will be discussing this hierarchical clustering, and we will be discussing this K-means algorithm, and we will be discussing what is this principal component analysis also we will be discussing. So these are all the things. It is mentioning supervised machine learning technique. Algorithms are trained using labeled data. Labeled data is nothing but target feature. So in the same way, unsupervised machine learning algorithms are used against data which is not labeled. So here everything is an input data. So everything we will be providing as an input data. So let us see. Let's go to the Excel. And algorithms is first one is K means clustering algorithm. Algorithm. So next, dimensionality reduction. So dimensionality reduction also, we will be having multiple techniques. So in the dimensionality reduction, we do have important concept called principal component analysis. So this will be PCA. And there will be multiple techniques also available. But at least you should be in the situation to understand about the important concepts. Why? Because when it comes to the clustering, there may be 6 to 10 algorithms. When it comes to dimensional reduction, there may be 5 to 6. Like the principal component analysis is one thing, and the singular value decomposition is one thing, and T stochastic neighborhood embedding is one thing. So like this, you do have multiple things, but at least you should be in the situation to explain during the interview. These are the concepts I know. Like that, you can explain. And next, here it is important thing classification and regression. In the clustering, we have already discussed. So these are the two algorithms and use cases. Use cases are problem statements. Anything is fine. So what is the purpose of using this unsupervised learning? What is the purpose of using this clustering algorithm? Let us take so use cases are problem statements. So when it comes to the unsupervised learning, mainly we will be using to cluster the data. So clustering means, for example, I do have customers' data with me. So I do have multiple rows of data. So we have seen, let us take an example of it. You see, this is the MPG data which we have considered for our data analytics. So here some of them related to country origin ESA, and some of them related to country Japan, and some of them related to ES. Yeah, just give me a moment. So this is my entire data. So this is my entire data. So by using this data set, I need to divide this ESA related data into one group. Let us suppose Europe into one group. So this Europe, let me take it as green color. Yeah. So it is taken as green color. And next, let me take it as Japan as another color. Japan, let me take as red color. And then say remaining ESA, let it be as yellow color only. Now, if you see the data, now I was able to cluster my data into multiple groups. Like some rows of data, I was able to divide into yellow color, and some rows of data, I was able to divide into green color, and some rows of data, I was able to divide into green color. So here you are able to divide it simply by using this Excel filtering methods, all those things. But whatever the manual work I did, I need to do it by using the machine learning algorithms. That is what this concept of unsupervised learning came into pictures. So by using this K-means algorithm, or by using this clustering algorithm, sorry, agglomerative clustering algorithm, you can divide your entire data into three parts. So it's up to you whether you want to divide your data into three parts or five parts or 10 parts. It's based on the problem statement. Here, how I am able to divide my data into ESA, Japan, and other country. In the same way, in retail domain, so whether it's in retail domain or whether it's in e-commerce domain, whether it's in healthcare domain. So, for example, I do have customers data. So, not customers data, patients data. So here in this patients data, I do have some patients related to cancer. So cancer patients, and next diabetes patients. So next, so some other like blood related infections. So by using my data set, so if the data like this, so there will be multiple columns related to cancer, diabetes, and blood. So by using simply this clustering algorithms, I can cluster these patients into multiple groups. Like one group will go to cancer, and one group will go to diabetes, and one group will go to blood infections. Like the same thing, the cancer related patients will be treated in one way, and diabetes related patients will be treated in another way, and blood infection related patients will be treated in another way. In the same way, for example, if you take our telecommunication domain, we will be using multiple networks and multiple mobiles. So some persons will be utilizing range of 10K, 5K to 10K, 5,000 to 10,000. And Another people range till 30K. So another people range 50K. Another people range 75K. 75K is 75,000. So next people range till 1.5 lakhs. So here, based on the range of the person economy, so based on his income, we can suggest the companies what they will do. They will take all of our data. So each and every data, wherever we are filling our data, it will be distributed among each and every company. So if you are providing our data somewhere, if you are giving our data to one bank or one retail company, it will go to each and every company. So that's why you will be getting calls from lot of banks. That's why you will be getting lot of calls and messages from multiple retail stores, all those things. So if I'm having capacity of 5,000 to 10,000, if I get offer on this 10,000 mobiles, immediately I will buy. If I get offer on 10K mobile, immediately I will buy. So if the person is having range of 1.5 lakhs, if he is getting offer on this 1.5 lakhs offer, 1.5 lakhs mobile with 10K offer, immediately he will also buy. So like this, the companies will divide the customers into the multiple segments. So here segments will be called as groups. So these groups of data, they will be utilizing based on our income level. They will be providing our offers. They will be attracting us, and they will be doing lot of sales. That is how the companies are behaving. That is how they are utilizing data. So that's why everywhere data is most important. To get this data itself, the companies are spending millions of rupees to store the data and to collect the data. So all this work will be done by the data scientists, that is machine learning engineers. We will be, so what we need to do to tell the group of people, each and every time they can't open Excel and they can't group it right. So here it is just 1,000 rows of data. I can do it. But what if I have 1 billion customers in my database, 2 billion customers in my database? The only way is I just need to use the machine learning algorithm. That's why this artificial intelligence came into picture to reduce the efforts of human beings. So what I will do, I will just apply my machine learning algorithm on the data, whatever I do have. I will simply I will simply group the customers into multiple groups. That is segregating the customers into multiple groups. Segregating the customers into multiple groups. So for this purpose, this unsupervised learning algorithms will be used. So this is the entire story behind this unsupervised learning. So now let us move on to the segregating the customers into multiple groups. So this is just like from customer's point of view. There are multiple ways. So for example, I do have dogs images, I do have cats images, I do have human beings images, I do have aeroplanes images. So if I want to cluster them into different groups, so aeroplanes images should go to aeroplane, human beings, cats, dogs, dogs. There I can use this unsupervised learning. If I don't have any target feature, like if I don't have any information of related to that dog, that cat, that human being, all those things. So simply dividing segregating human beings cats, and multiple groups. So now in the supervised learning, so here you will be getting data like this. Let us take this example, the sheet. This is the problem statement. So here my data will be like this, like image 1, image 2, image 3, image 4, image 5. Like this, you will be getting thousands of and lakhs of images. Simply, you will be getting image as an input data. So what we need to do? We need to convert this image into numerical data. So after that, we can apply the machine learning algorithms, like whatever the clustering algorithms we do have. We can apply any one of the technique. Either you can use K-means technique, or you can use agglomerative technique, or you can use any other techniques. It's fine. If you see, there is no target feature. Here, everything is input data only. In the unsupervised learning, everything is input data only. Let us frame the same data into the classification. Before going to classification, let us understand what is classification, what is regression, what are the algorithms in classification, what are the algorithms in regression. See, this is very important things. If you are not able to distinguish what is unsupervised, what is supervised, what is clustering, what is classification, what is regression, then it's waste to learn the machine learning. This is the basic concepts we should learn. I know some of the guys, they don't know this classification or regression, even though they completed courses somewhere. But you should strong in all these theoretical concepts before going to the real-time projects, all those things. So the first classification algorithm is logistic regression. This is the first and important technique. So logistic regression algorithm. So these are algorithms. Next one is ANN classifier. Everywhere it is algorithm. Next one is support vector machines. You should by heart all these terms. Next one is naive-Bayes algorithm. Next one is entry classifier. Next one is forest classifier. This parity and Gaussian classifiers. So like this, the same format, we do have algorithms for regression also. For regression, whatever the logistic regression algorithm formula, the same formula will be used for linear regression also. So the next thing is same ANN regression. We don't have support vector machines. We do have support vector also. Support vector regression. So if you are using for classification, these are support vector classifieds. If you are using for regression, it is support vector regressors. So there is no naive-Bayes for regression. Only naive-Bayes is for classification. Next, decision tree. So next, random forest regressor. So next, so tagging and the boosting means XGBoost here. So here the algorithm will be called as XGBoost. So all the algorithms related to machine learning. So first one is logistic regression in classification, linear regression in regression, and KNN regressor, support vector machines, support vector regressors, naive Bayes. So this is naive Bayes algorithm is nothing but naive Bayes classifier. Next thing is patient tree classifier, random forest classifier, XGBoost classifier. Same here also, linear regression, KNN regressor, support vector regressor, patient tree regressor, random forest regressor, XGBoost regressor. So these are all the multiple things related to classification and regression. So now let's tell me what is classification. The next interview question is what is classification? Can any one of you tell? We have already discussed this concept. Just quickly, what is classification? Anyone? Just unmute and so in the classification, if you are trying to predict class label, target feature like class label. So here class labels could be 0, 1, 2, 3, 4. Yes. No. Satisfied. Satisfied. Good. Bad. All these things. So if you are trying to predict target feature like class label, that will be called as classification problem statement. So same scenario, if you are trying to predict continuous values. Like sales value, 100,000, 3,500, 5,000, 15,000, or stock prices. Stock prices, like for example, if you take any stock price, so if you take TCS stock price, like 1,500, 1,550, 1,540, 1,650, so 1,780, like this. So if you are predicting classes like class labels, it will be called as classification. If we are trying to predict values like continuous values, this will be called as regression. So now, again in classification, we do have two types. One is, again in classification, we do have two types. So one is binary classification. Next one is multi-class classification. The binary classification, you will be having only two class levels. You will be having only two class levels. That is 0 or 1. Or 0 or 1 is one type. Either you will be getting data directly in 0, 1 format, or you will be getting data in the format of S or S, comma, no. So in the multi-class classification, you will be having more than two classes. So you will be having more than two classes means that is 0, comma 1, comma 2, comma 3. Let us suppose. Here I have taken how many classes? I have taken 4 classes. It can be up to. It can be up to any classes like 10, 20, 50, 100, whatever it is. More than 2 classes. So if you take it in the text, same thing, good, bad, neutral. In the same scenario, let us take another example. Satisfied? Well, not satisfied. These are all the concepts related to clustering, classification, and regression. So let us take same example, whatever we have used for clustering, and the same example we can apply for classification also. Let us form as. So here what I am doing, I am dividing all of my images data into multiple groups by using the clustering technique. Same images data. So next, here the problem statement is segregating human beings, cats, images, aeroplanes, machinery into multiple groups. Now, when it comes to the classification, we need to classify the images into multiple classes. Like what are the classes we do have? Whatever the names we do have, all these are classes. Human beings is one class, cats is another class, animals is another cat, another class, aeroplanes is another class, machinery is another class. Let us take so like for example, human beings will come under 0 class. If you want to divide human beings into 2 types like male and female, we can do, that is up to us. Based on the problem statement, we can do anything, whatever. So cats is 1, animals is 2. So this numbering also up to you. You can give any numbering here. So aeroplanes 3 and machinery. So how many classes we got? 4 classes we got. So now the data in this, we do have only one feature, that is images. We don't have any target feature. So we do have images here. So here also you will be having images like the same. But you will be having another category like images. This is input data, and you will be having target feature also here. That is image class. The name could be anything. This column name could be anything. So for example, image 1 related to human being, image 2 related to cats, Image 3 also related to cats. Image 4 related to animals. Image 5 related to aeroplane. And next, image 6. Image 6 related to machinery. So like this, you will be getting data related to all the features. So in the next phase, what we will be doing, we will be converting all these images into numerical data. That is, we should do machine learning algorithms and systems won't understand directly. We should convert everything into numerical algorithms. The same thing, this class also. Here it is in the categorical format, right? We need to convert this categorical format also into the numerical data. So what we need to do, the same image class will be replaced with numerical data. Image class, like human being, we will be labeling with the 0 and cats 1, same cats also 1, animals 2, aeroplane 3, machinery 4, and human being it's already there. So here also it is 0. So now your data is ready. So what we need to do, we need to pass this input data as an input data to my machine learning model, and we need to pass this output data, that is target feature, as an target feature to my machine learning model. So by using classification algorithms, I can predict. For example, how it will be useful. So I was able to train the machine learning model by taking this images data. If I show, if I feed any new incoming image to the model will predict, okay, this image related to this. So this image related to cats, this image related to human being. Like that, it will predict. So here in this classification, we will be having target feature. But in the clustering, we will be having only images data. That is the difference. There is no target feature here. There is no target feature. Here it will be target feature is there. So let us suppose the same thing let us use for regression. The target feature will change. So here the problem statement is we need to classify the images into multiple classes like human beings, cats, animals, aeroplanes, machinery. So in the regression, let us frame the problem statement. We need to predict how many times same whatever the thing we do have, human beings, so normally when it comes to the food scenario, only it will come under creatures only like human beings, cats, animals. Let us take these three examples only. So let us take birds also. We eat each and every day. This is the problem statement. The same problem statement, we will be taking images by seeing the images itself. By seeing the images, I should tell how many times they are eating. So let how many times? So for example, human being eating 3 times, cats let us suppose 2 times, animals let us suppose 5 times. So there is no aeroplane will come and there is no machinery data. We can ignore these two. And human being 3 times. So like this, here in this example, we can take these images or we can use this image classes. If you don't want to use, we can remove this image classes. We can take only images and we can predict this how many times. So this images is my input data and this how many times is my output data. This is, we have already discussed what is input data and what is output data. Our input feature or output feature. Same. Here, input data, output data. Same. Images only input data. At least by seeing this, we can understand. In clustering, there is no output data, only input data is there. By using the clustering algorithm itself, we need to divide. But in the classification, we do have clear labels, like it is telling. Regression also is telling clearly. Like this is the complete introduction and complete algorithms about the machine learning. So now next what we need to do, we just need to take one data, we need to apply K-means algorithm and we need to see. Same, we need to take one data set, we need to apply agglomerative clustering and we need to see how it is grouping happen. And next thing is we should take one data set and we should apply logistic regression, KNN, support vector, naive Bayes, Bayesian tree, random forest, execution. Same regression, linear regression, KNN, support vector, Bayesian tree, random forest, execution. Like this, we need to apply each and every algorithm and we need to check the accuracy step by step. So as of now, any doubts? So after this completion, we will be discussing about this concept. Natural language processing. For this large language, out of applying this algorithms, we will get each and every some miscellaneous concepts in between. Like we have seen, this images data for classification. So I got data like this, images and images class. I do have this human being cats. How I will be converting this into 0, 1, comma 2, comma 3, comma 4. We have already discussed during this lunch. All these things will come during the project one by one. So I am expecting each and everyone should be clear with this unsupervised learning and supervised learning, classification, regression, and these algorithms, all those things one by one. So now let me give one assignment for you guys. You can search it anywhere. Five or 10 use cases or problem statements. This thing everyone should do and everyone should explain on tomorrow's session. There is no excuse. 5 are use cases or problem statement related to clustering. You can refer anywhere. You can refer any Google. You can refer any chat GPT. You can refer anywhere. I don't want. The only thing is you should make a note of problem statement. Like whatever the problem statement here I have written, right? We need to classify the images into multiple classes like this. In the same way, you need to form it. So clustering 5 is enough, but 10 use cases minimum in classification. Use cases, use case is nothing but problem statement. Okay, you should maintain this terminology. Use cases related to classification. Same 10 use cases related to regression. And this is important, guys. Each and everyone should complete. All right. So tomorrow session, you guys should explain clearly what is this classification, what is this regression. If you're able to complete these questions, if you are able to provide answers to me, then only I will move on to another question. If not, I won't move it. Everyone should learn what is clustering, what is classification, and what is regression. Everyone should answer this interview question. Okay? Any doubts till now? You can ask your doubts. Everyone clear? At least send in the team chat, man. I will get to know whether you understood or not.
Yes, sir, understood.
Okay. Okay then. So that's all for today. We'll connect tomorrow. So you understood the assignment, right? Whatever I have given to everyone.